All right. It says set up an integral for the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. Then use your calculator to evaluate the integral correct to 5 decimal places. All right. All right. So first things first, x squared plus 4y squared equals 4. What's that going to look like? Yeah, that's going to be an ellipse. So let's just, well, we can do it this way. This will be easy enough. So let's see. We have 2, 0 should be a point. Negative 2, 0 should be a point. Negative 1, 0, and then positive 1, 0. Is everybody okay with how I came up with those 4 real quick? Like if y is 0, what can x be? 2 or negative 2, right? Because x squared has to equal 4. If x is 0, what can y be? 1 or negative 1, because y squared has to equal 1, right? Everybody's okay with that? So that'll just like is enough to get me a picture of my ellipse. Is that okay with how we did that now?
Yeah. Should the bottom 2 points be flipped?
Yes, I'm sorry. Yes, absolutely. Yeah, of course. That's a classic Mr. Kulik. All right, so we have negative 2, 0, 1, 0, 2, 0, negative 1, 0. So here's our like ellipse. Everybody's okay with that? And then we're going to rotate it about the line y equals 2. So is this thing convex or concave? Concave, right? There's a hole through the middle. Everybody agree? How can you tell there's a hole through the middle? Look, the axis of rotation is like a bunch of space where it's not touching the figure, right? So it's got to have a hole through the middle. Everybody buy that? It's like a tube of some kind. Okay. So what does that tell me then? We're integrating using the washer method. We use washers. So we need the R inner and the R outer, right? Yeah. Are we integrating with respect to x or y? X, right? Because we want to be taking our slices perpendicular to the axis of rotation. So we're going to be moving in the x direction as we're taking our slices. So like this would be my R inner or outer? Inner. Mm-hmm. And then like that would be our outer then, right? Okay. So let's do the R inner first. How far is that? That's 2. How far is that? Y. So R inner should be 2 minus y. Now I need to rewrite my equation now in terms of y, right? Oops. So I subtract the x over, or the x squared over, excuse me. Divide both sides by 4. And then we square root both sides, right? We get this plus or minus. But which piece do I really want? Do I want the plus part or the minus part? The plus. Very good. Why? Because the plus part is like the top half. And the minus part is going to be like the bottom half, right? So this should be 2 minus square root 4 minus x squared over 4. Everybody feel okay there? All right, let's do our outer. What's that going to be? So it's going to be 2 plus y, right? Because this distance right here, again, is a y. But we have to be careful, because what's the sign of that y? Negative. So it's not really 2 plus y. It's 2 minus y, because we're subtracting a negative, because that radius has to be a positive number. If I did 2 plus y, it would end up being like that point again, right? Did you guys kind of catch that? Yes?
If it's like equal on both sides of the axis, like the same on the top and the bottom, couldn't you use like the top point for y and then add it? Because it would be like mirrored.
Sure. Yes. Yeah. So if we do it this way, we're using the minus piece. And it's going to come out to be the same thing, Jacob, whether we thought about it your way or that way, right? I just want to be careful, because in the case where it's not a mirrored reflection, like if this was shifted, so it wasn't centered at the origin, you couldn't get away with that there.
Also, for like this one, it could be 2 plus y, but what if it's not?
It could be 2 plus y if you're using the plus from the plus or minus, right? You'd have to still be using the positive side, which is the same thing as minus the negative side, which is probably the way you'd want to think about it, because if it's not symmetric, the 2 plus is going to get you into problems. Katie.
Wait, so how do you use the positive y?
So if I look at my picture, the endpoint of Ri is on the positive part of my ellipse, and the endpoint for RO is on the negative part of my ellipse. So that's how I knew to use, the positive here and use the negative there. So far, so good? All right. So we're going to integrate from what to what? Negative 2 to 2. We have pi, and then r outer squared minus r inner squared dx. Yes, Rita. You could, but it says to just type in your calculator anyway, so I wouldn't bother with it.
Okay.
But you could definitely, if you wanted to, you could write this as 2 and 0, and that would be okay. Still be fine. But I wouldn't bother with it if the direction's telling me it's going to my calculator anyways. It's not saving me really anything to do that. And if I'm mistaken where it's not perfectly symmetrical or something, and now I've made a big boo-boo, trying to get fancy when I didn't need to get fancy because it's going to go in my calculator anyways. Does that feel okay?
Yeah.
Okay. And then there was a part B with a different. Do you want to do the other?
No, I think just like the ellipse. That was.
Yeah, you're going to be using X coordinates instead of Y coordinates for that one, so you'll be solving for X instead of Y, but I think the setup's going to feel almost identical. You're welcome. Isabel. 6.2, number 17? Sure. I suppose I should have probably looked that up in the back of the book to make sure we didn't make any blue there, but that felt pretty good to me. Okay. If it turns out I was wrong and you catch me, let me know. And we'll give you an extra credit point or something for the next test or something. Feels like a good standing rule, right? If you see Mr. Kulik and we're doing a homework problem and we don't check it, it turns out it's wrong and I make a mistake and you figure out what's wrong. Yeah. First come, first serve on that, though. All right. Isabel, we're looking at number 17, you said, right?
Yes.
Okay. So let's start first by sketching out our picture. So x equals y squared. What's that going to look like? It's a parabola, but it opens to the right instead of up and opening up. So like it's going to be like, for when x equals 1, y could be 1 or negative 1. When like x is equal to 4, that's 1, 2, 3, 4, y could be 2 or negative 2. It's kind of looking like that. How about this part? It opens the other way because I see the y is negative, right? And it starts at 1, 0. And it's going to like open the other way. So when x is 0, y had to be 1 or negative 1. So it's going to look like that. So here's our shaded region in there, right? And then we're rotating about the line y or x equals 3. So 1, 2, 3. All right. Is this thing convex, concave, or got a hole? It definitely has a hole, guys. Right? Look, there's a gap between the shaded region and the axis of rotation. Right? Definitely has a hole. Everybody agree? Now, which way should we be slicing? Horizontally, right? Which means we're integrating with respect to y. So like that's going to be my r inner. And like that would be like my r outer. Everybody feel okay there? Okay, let's construct those then. So for r outer, we'll do that one first because I'm still on the pen. How far is it from there to there? 3. How far is it from there to there? X. x. So our outer should be 3 minus x. What's the problem, though? What are we integrating with respect to? Y. So we got to get that x out of there. What should I replace it with? Y squared. Okay. Now let's do the R inner. How far is that? How far is that? What x is that coming from, though? It's from the green line, right? It's the green line's x. And again, we're still in the same boat. So far, so good. Rita?
To add the extra x for like the R inner.
So we're looking at that distance, right?
It's not like that. I don't know what I'm asking.
Well, they all have. So the R outer is going to the red line, right? The R inner is going to the green line. Does that?
Oh, sorry.
It's okay. I had scrolled too far for you to see it anymore, so. Yeah.
I was like, I don't know how that disappeared.
So pi times the integral from R outer minus R inner dy. What are we missing, though? Our bounds of integration, right? How are we going to solve that or figure out what those are? Yes. So we can set the two equations equal to each other and solve for y. Again, we're solving, make sure we're solving for y and not x because we're integrating with respect to y. If you have access to a calculator on this problem, what else could you do? Graph and find the intersection. So add the y squared to both sides, divide by 2, square root both sides. Oops. Just rationalize the denominator along the way. I have that. Correct. So we don't care what the x is, but this is something comma negative root 2 over 2. And that point up there is something comma positive square root 2 over 2. Again, we don't care what the x is. We could find it if we wanted to. All we have to do is plug that y back into either of the equations. But, like, I don't care. Do you care? I don't need it. Let's not get it, right? All right, so if I'm stuck doing this one by hand, I'm definitely going to take advantage of that symmetry argument, right? Because if I look, the lower half of this figure is going to be identical to the upper half. Yeah, the square root of 1/2 is the square root of 2 over 2. I just rationalized the denominator. Yeah, no, totally fine answer, asking and answering. So along the way, I'm going to FOIL that stuff out. Those guys cancel out. And when I combine like terms, I have 5 minus 10y squared. And then from here, we're just stuck doing like terrible grinding, it seems like. And I don't know, I'm stopping here if it's the AP Calculus exam. Like everything is plugged in. I'm not trying to simplify this. I'm not going to waste a bunch of time doing that. If it's you in the homework, I would just type that into my calculator and double check the decimal comes out to be the same thing as the decimal version of whatever the back of the book's answer is. I wouldn't waste a lot of time simplifying. You guys cool? Yeah. Isabel, that feel okay?
Just have like one question. Earlier on when you were citing like the R in or outer,
Yeah.
did you plug in for the X value? Like
I use that for the R inner. And I used that for the R out, or the R inner was the green and the R outer was the yellow.
okay.
Is that what you're asking?
Yeah.
Okay. Yeah, perfect. Beck.
You do 42 from 630.
Sure. You said 43?
42.
42. All right. So if I look x equals y minus 3 quantity squared, what's that going to look like? It is a parabola. Which way is it going to open? Left or right? No. The y squared is going to be positive, right? So it opens to the right. So let's fill in a couple of values, right? If I pick y to be 4, x should be 1, right? Everybody agree with that? And if I pick y to be 2, x should be I'm sorry. I did that wrong. If I pick y to be 4, x should be 1. So it should be 1, 2, 3, 4. There we go. If I pick y to be 2, x should be 1. Everybody agree with that? Well, I'm just trying to think of things that are going to be nice when I square it.
This is just to make a picture.
Yeah, I'm just trying to get a picture. If I pick, say, y to be 3, x is going to be 0, right? So this is probably enough for me to like see my picture coming here. You guys buy that? All right. Oops. And then 1, 2, 3, 4. So x equals 4. So this is like my shaded region then is like that stuff, right? And then I want the line y equals 1 is what we're going to be rotating about. Everybody feel okay there? I'm going to check real quick and figure out what these endpoints are, or what those intersections are. Specifically, I'm interested in that one, but if I get one of them, I'm going to get both of them. So I know those are 4 comma something, right? Because the purple line is x equals 4. So I just need to solve that equal to y. So square root both sides. So I'm going to have 3 plus or minus 2 is equal to y. So 3 plus 2 is 5. 3 minus 2 is 1. So that's the points 4, 5, and 4, 1. Everybody feel okay here? All right. So what's this thing going to look like? Convex, concave, or got a hole? Concave, right? I can see that because it is touching the axis of rotation, but there's still like a gap between the function and the axis of rotation, right? So there's going to be some indentation in my figure, right? It's going to look kind of like a really dumb-looking vase, or like a funnel cup, right? A cup that's kind of shaped like a funnel, except it doesn't have an opening at the bottom. It's like, who drinks out of that? I don't know. All right. So since it's concave, I'm either going to be needing to use a washer method or a shell method, right? I can't do discs because it's got a hole or an indentation in it. If I tried to do a washer, that would be like my R inner, that would be like my R outer, right? What's the problem there? They're on the same curve, right? And it's not exactly going to be easy for me to rewrite that. Well, I guess it wouldn't be so bad, right? Because this could just be x equals y minus 3. And this one would be, oh no, yeah, it would be bad. So I'd have, if I wanted to do that, let's see what I would have to do. Because I think it's still going to be okay. So I square root both sides. And then I put the 3 over. So this part of my curve is y equals 3 plus square root x. And that part of my curve is y equals 3 minus square root x. So I think I could do it that way if I wanted to do a washer. Is that okay so far, Beck? So if you want to do a washer, I think that's going to be okay. So the R inner is going to be this distance, which is y, minus this distance, which is 1. And my R outer, again, is going to be y minus 1, but it's a different y. This one is 3 plus square root of x minus 1. It's going to be 2 plus the square root of x. So I think that should work. Again, I typically prefer washers over shells. I think it's a little bit more intuitive, visually anyways. The shells are hard for me to imagine in my head. The washers feel very natural. But that ought to do it. Let's double check this one. I suspect they would have wanted you to do a shell here, but this was 42, correct? Yeah, they did do shells when they did it. It's curious what that comes out to. I feel like that should be okay, though, what we did. Let's try it real quick. What do you guys say? Probably a good idea, right? Yeah. Yeah, that worked. So again, the back of the book did suggest using shells on that, but what we did there was perfectly appropriate, was okay. Since it was easy to get to split the thing into two different equations, that one was easy to do without having to shell it. Do you want to do it as shells?
No, I just wondering, so that's the reason you put that equation in terms of y, so you got the two different equations for the radius?
Yes, I was going to need the radius in terms of x anyways if I was going to do it. But I had to be careful about, I had to split it into two separate equations so that I could do a washer. If I had just left it as y plus or 3 plus or minus square root of x, there's nothing I can do with that. I had to split it like 1/2 is this equation, 1/2 is that equation. It was going to be okay. Now, if this was instead like x equals y cubed minus 3y or something, I got nothing to do. That's shell all the way. There's nothing I can fix that. I mean, I could, but like it's going to be like a whole afternoon of me like trying to remember how to use like the closed form quadratic or cubic formula to do that, which I am not really interested in doing. Isabel? Yeah. What's the shell formula again? Yeah. So I'll use a different color over here. What haven't I used at all yet? We'll use this funny blue. So volume is the integral of 2 pi r h and then d whatever x or y or depending on what we're doing here. So we're going to be doing y's here, right? Because I'm going to be building my cylinders or my cylindrical shells like this way, right?
Like when it's being rotated. I can understand like the equal pieces, but like if you don't have a picture, isn't it supposed to be perpendicular to the axis of rotation?
So yeah, so here's what we mean. So the shells that I'm building are like doing this. So like this is my radius and that's like my height. So the radius that I'm picking is like, yeah. Does
Will
that?
we always like? I mean, I'm guessing we'll always have a picture, but I don't know. Yeah, go ahead. Sorry, thank you.
Is that?
Yeah.
I don't know. Like I'm trying.
No,
right?
You're good.
Okay. So if this is my radius, what's that? What's this distance got to be? That's y, right? Because that's just a y coordinate, right? We've gone up y units. And this is 1. So the radius, just that little spot there, is y minus 1. Does that feel okay there? The nice part is that the height of my function is just going to be the, oops, nope, that's not right. So this is x, and that distance is 4. So that should be like 4 minus x, which would be 4 minus that. So my integral should go from 1 to 5 along the y's. 2 pi times y minus 1 times 4 minus y minus 3 squared dy. Right? That's got to be. I'm seeing a lot of unhappy faces with what we just did there. Can you help me out a little bit and tell me like where we lost you?
So like
Yeah.
from 1 to 5.
Oh, okay. So I'm integrating here, right, along the y-axis. So starting at 1, ending at 5. Does that feel okay? All right. Isabel.
I'm just like kind of struggling to see what
Okay. That's 1, 2, 3. And there and there. And 1, 2, 3, 4. Okay. So when we're building our shells, that distance, like right there, would be our radius for some shell. And then like that distance right there would be the height for that shell. So I know from here we've gone y units up. And I know right there is 1. So my radius should be y minus 1. And if I go over here, I know that this distance is 4. And I know that distance is x. So h is 4 minus x. And the x in this case was y minus 3 squared. Does that help clean up the picture a little bit there? Sure. Tessa? I think the directions on these say specifically to just do it in your calculator, right? Am I wrong on that? Yeah, I mean, I would tell you guys that there's nothing wrong with like doing one of these as a setup and then check it on your calculator and just move on to the next one rather than spending like an extra 10 minutes per problem, like grinding through the integration. Where that's helpful to do it, it's nice practice, but like I don't have an extra whatever time to do that for every single one of these problems. Isabel?
So you just integrated from 1 to 5 because it's in respect to water.
Yeah, because the integration we're doing is along this, right? That's where each time our R is changing, it's going from 1 to 5. Does that feel okay? Yeah, Rita.
So for like the washing method, you're always like, integrating with respect to like whatever you're rotating around, but then like for the shell, it's like the opposite.
Yeah, probably.
Okay.
That sounds right. Okay. Tessa? I'm sorry, you said something real quiet and I couldn't hear. 44, the same section. That's like a weird word problem, it looks like, huh? What's up?
Should we always try to work out the integral or no? Like, or just put in our calculator?
On the test.
Yeah.
You'll be expected to do both. I probably, like, this integral right here, if you did a shell method, would stink to do by hand. Like, that's a lot of extra foiling and, like, crap you have to, like, walk through to get to it. Probably wouldn't ask you to be able to do that by hand. Unless it's, like, a 5-question test. Right?
Yeah.
So, like, very much am I trying to keep in mind where are we going to have to spend our time to do this, and what do I really want you to show me using the time that you have available? So I probably wouldn't ask you to grind something like that by hand, although you should be able to do that. But in a test setting, like, unless I only ask you like a couple of things, I don't think I'd expect you to grind that by hand. If that kind of answers your question.
Yeah.
You know what I mean?
Yeah.
I'd rather have you do a lots of setup and use your calculator to get through the integration, because I feel like I learn more about what you're able to do.
Yeah.
But surely you should be able to do integration by hand. But this one just like would be time consuming.
It's a few like tough ones, but wrong ones.
Yeah. We'll just call it time consuming, right? All right, it says let T be the triangular region with vertices yada, 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 and let V be the volume of the solid generated when T is rotated around the line X equals A, where A is greater than 1. Express A in terms of V. Okay. So I'm going to start with a picture. So we have 0, 0. I'm going to do 1, 0, and then 1, 2. Everybody okay with that? And then we have, here's our X equals A. Everybody's okay there. We're just told that A has to be greater than 1, so I know it's over there somewhere. Doesn't really matter. So far, so good? All right. And we're rotating here. What's this thing going to look like? Has a hole through the middle. That's really what we care about, right? Everybody agree? Okay, that's what I care about anyways. So I'm going to try doing this with a washer. It's a pipe that's fat on one end and skinny on the other, right? But it's just like, a pipe that thins out as it goes. Everybody's good with that? So Ri is going to be A minus 1. Notice that that's constant, right? Because no matter what, like where we're picking to make that radius Ri, it's going to be the same radius for any value y that we're choosing, right? Everybody feels okay there? Okay. For our outer, it's going to be A minus something, but I need an equation for that line. Can we do that? You better be able to, right? So we're going from 0, 0 to 1, 2. Y equals 2x. Everybody buy that? We know the y-intercept is 0 because it's going through the point 0, 0. So all I need is the slope. Slope's clearly just 2. 2 minus 0 over 1 minus 0. Everybody's okay? But I need that in terms of y, right? So our volume is going to equal the integral from 0 to 2. How do I know 0 to 2? Oops. Yeah. Right, if we're integrating along the y-axis, I know the point was 1, 0, and we know the other point was 1, 2. Oops. Stick a pi out front there. Our outer squared minus our inner squared square root dy. And then it asks for, what did it ask for here? Express A in terms of V. Ugh, gross. What am I going to do now? We're integrating. So I'm going to have to FOIL all this junk out. A squared minus y plus 1/4 y squared minus a squared. Oh, shoot. That should be minus ay plus 1/4 y squared. And we have minus, yeah, go ahead. It should be plus 2a and then minus 1. Does that look like I foiled that okay? So there's that. I'm going to divide that pi over. And let's see, I have minus a times y squared over 2 plus 1/4 y, that was a y squared there, so that should be y cubed over 3 plus 2ay minus y from 0 to 2. Okay. Let's see. That reduces there. That'll reduce there. So I have minus 2a plus 2/3 plus 4a minus 2. So that's going to be 2a minus 4/3. So I'll add that 4/3 over and then multiply by 1/2. Maybe get that. It seems like an answer, right? Let's see, did Mr. Kulik do it right? Did I lose anybody along the way? It was just kind of like an annoying problem, right? Just looking in the right section would be a better idea, right?
The Gaussian method always works for variable load. Right?
Always?
Or is it like the shell prep?
So you'd want to use shell or washer if there's a hole. You could have done shells on this one too. That's apparently what the back of the book did. They got the same answer I did though. I thought this seemed obviously like something I would want to use washers on, but yes, you can always use both if there's a hole. It just sometimes like the algebra is kind of impossible for one or the other.
Yeah, is there like a hint to like spot to know what to do? Or we can recommend.
So here's what's going on, right? Remember when we did this one a minute ago? The reason why the book wanted to do a shell is because we had to solve this equation for y. Now that turned out not to be too hard algebraically, right? To get the y by itself. If instead, hypothetically, this had been like x equals y cubed minus 3y, I have no flippin' idea how to get y by itself. So if I'm stuck trying to do an algebra like that, it's like I'm going to shells. That's what I mean. So by spotting, it's going to be like, okay, do I need to solve like this equation in terms of the other variable, and it's like impossible for me to do so because it's like a terrible polynomial that I have no idea how to solve? It's probably shells. But in what we're seeing is in a lot of these cases, if the algebra is not bad, washers work fine, right? Cool?
Yes.
Here's the good news I'm going to tell you right now. The AP exam isn't going to ask you anything that can't be done with obviously with washers or shell or washers or discs.
Oh.
They're never going to ask you a question that has to be a shell question.
Oh, okay.
Your first year calculus teacher for sure will give you shell questions, which is why we're doing it, why I'm spending the time to do it, because I know that you will be doing this as a calculus student. So I don't want it to be like, oh, we didn't do that. We're doing it because I'm going to try to do a good job as I possibly can. And we're going to do stuff even though you might not have to do it for the AP exam, but you will have to do in your college calculus 1 or 2 course. Does that feel any better?
Yes.
So in general, and again, on the AP exam, could you do the shell method? Absolutely. Wouldn't be wrong to do it. But they will not put a question on there that cannot be done easily with washers or discs.
You're sure.
So if you wanted to know a method, for sure, washer would be one that would, yeah. Isabel. I mean, I had other stuff that I'd like to do today, but if we're being productive, we can keep going and being productive. If this is working for you guys.
I have another one too.
Yeah, that's fine.
Can you do number 9 on
6.3, number 9. Ah. All right, and you wanted number 9? All right. Okay. So let's start with a sketch. So we have x equals 0, that's the y-axis. We have y equals 1. And we have y equals 3. Okay. So if I plug this in, when y is 1, what does x have to be? 1. Okay. When y is 3, what does x have to be? When y is 3, what does x have to be? 1/3, right? So it's going to look like that. Yeah, that's right. Is that okay? Or you could have just said, like, this is y equals 1 over x. Right? Or x equals 1 over y. And we're rotating about the x-axis now. Everybody's okay there? What's this thing going to look like? As a hole, right? That's the thing we care about. Everybody see there's a hole? Okay. What's it going to be? It's going to look like a pipe that's like skinny at the top and like it's real wide and flat at the bottom. Yeah, like a volcano. Great analogy. Perfect. Look at you seeing it in 3 dimensions. Except it's going to be like a sideways volcano, right? Yes.
When they like rotate it like around the axis, can you just like make the y
Can you make the y's what?
like negative?
Can you make the y? I mean, yeah, absolutely. So you want to say like, here's like y equals -1, and here's like y equals -3. I put that in the wrong spot. Then you have like this thing coming all the way down. So you have like another like one of these down here. Oops, wrong way. Sorry. Like one of those guys. Yeah, absolutely. If that helps you picture it, for sure. So the shells that we're going to be drawing, so like you'd have like, this would be like your radius. And then like that would be your height. So you're getting like and like your, you know, like you still have like the rest of your volcano or whatever. That's kind of like what's going on. Is that picturing it at all? So the height is like that distance. It's like how tall where you were at in the volcano, like how tall the volcano is. Yeah.
And like the width.
So it's
of it
like
is
the radius.
dy, right?
Yes.
Okay.
Yeah. And that's like your dy. Yep.
Gotcha.
I didn't draw it sideways. I should have drawn it sideways, but like this was going to be a hard enough picture for me to draw like up and down sideways, so I'm sorry about that. But yeah, as the radius gets bigger, you get like, you know, like that cylinder, right? Okay, just kind of see what's going on, where you're just kind of like Russian nesting doweling it.
Is the radius
It's always from the axis of rotation. So like this is our axis of rotation, right? So it's always from that into the function. Yeah. Okay. So this radius is going to be, oh, I shouldn't have drawn it that way. That's not really what I mean. Yeah. Okay. Yeah, that's fine then. All right, sure. Okay. Everybody's okay? So the radius is just the y, right? And this height is just going to be like the x, which is 1 over y. Everybody agree? So our volume is going to be the integral from 1 to 3 pi r h dy. Oops, 2. Right, I just forgot the 2 from the formula. It's 2 pi r. Everybody's okay? What do you notice? So is this like the easiest integral that's ever integraled? Pretty near, right? That's one I would expect you to do by hand, right? That's not a time-consuming integral by hand. It's okay? Jacob?
So that y, so y still there?
Because the antiderivative of a constant is like cx or whatever. So the antiderivative of 2 pi is 2 pi y, in this case, since we're integrating with respect to y. Isabel, are you happy?
Oh, yes.
Okay. You're really challenging my art skills today here, guys. That's fine. I just feel sorry for you that you have to look at my terrible drawings. Katie?
Number 23.
Same section? Okay. All right. Oh my goodness.
Sorry.
So cosine to the fourth, or y equals cosine to the fourth x, and y equals negative cosine to the fourth x between negative pi over 2 and positive pi over 2. Sweet. All right, we can do this still. Watch Mr. Kulik do it with no calculator. All right. Cosine of negative pi over 2 is cosine of 3 pi over 2, which is 0, right? So what's cosine to the fourth of negative pi over 2? Well, that's just 0 to the fourth, so it's 0. And what's negative of cosine to the fourth of negative pi over 2? Well, shoot, that's still 0. So let's make that, I should use a color. So there's 0, okay. Cosine of 0 is 1. So cosine to the fourth of 0 is 1 to the fourth, or still 1. And negative cosine to the fourth of 0 then should be negative 1 to the fourth, or negative 1. And then obviously cosine of positive pi over 2 is still going to be the same, right? I think it's going to look like this.
This is a skill I should have.
I don't know, man. Like the unit circle stuff? Should you have that? I mean, yeah.
To an extent.
Would the AP people expect you to like generate that graph by hand without doing anything else? No, man. No. And actually, I guess when I look at this, it's a little bit more like looks more like an eyeball or something. Yeah, like the way you draw an eye, like almond shaped or whatever.
Eyeball, I was in pie.
No.
Eyeball.
Oh, sorry. Yeah. Piebald's a word though. What's that mean? It's like fat or something.
I don't know. Like a 3D version of pie. Like,
Right? That's a word I've read before.
I'll Google it.
Pie balls.
Yeah,
or,
BALD.
yeah, having a regular patch of 2 colors,
Oh, there you go.
typically black and white.
Yeah, so like the clown with the checkerboard clothes. There you go. All right. Anyways, there's our picture. I know, Mr. Kulik, I'm not going to be able to do that myself. That's fine. And then we have the line x equals pi. So that's like out here. It's okay. Everybody's good. All right. It's okay with the picture?
Yes.
So if I draw some radius, there's some radius, right? What is that radius going to equal? Mm-hmm. Yeah, very good, right? That's x. That's pi.
So who's from the line of X? Oh, I didn't really.
I just drew an R.
Oh,
I hope that it would make it easier for you to see what it was going to, pi minus what was going to be by drawing it where I drew it. And then this is our height, right? What's that going to be? Well, it's going to be this y and then that y, right?
because they cancel out. Negative, so it is two. Oh, no, it's two. No, it's two cos x. Yeah.
Yeah, I would think about it as the top minus the bottom. But yes, 2 cosine to the 4th x. However you got there was going to be okay. So when you were shouting them out, you were like, I got it. Okay. What are our bounds of integration going? Good. And we have 2 pi, and then our r, and then h dx. And I think the directions specifically say to use your calculator to do this, because I'm not sure I know how to do the integral of cosine to the 4th x by hand. I could probably figure it out as probably a u sub, but you have to break it into like cosine x times cosine cubed or something, or you'll have to break it up in a weird way that I'd have to guess and check it a little bit. Jacob?
Radius squared.
No, because it's a shell. It's 2 pi r h.
Okay. Oh.
It's not a washer, which is r outer squared minus r inner squared. Isabel.
So when we're finding the height, why are we subtracting the y on top minus the y on the bottom?
Because the y on bottoms are negative y values, and a height is always a positive.
Yeah.
So if I want like the distance from like -4 to like 6, I would do 6 minus -4 as to get a positive 10, right? You could think about it that way, but be careful putting absolute values into your calculator.
Well, just like,
Yeah, that's fine. It's fine to do it that way. That's okay. Here's where you would potentially get into trouble, is if one function is on bottom and it's a separate discrete function on top. Now, I don't think that you would get that, but that's a place where like this reluctance to do minus the negative, which we all seem very reluctant to want to think about it that way, would run you into problems. Is trying to shortcut around having to do minus the negative. It's okay. The way you're thinking about it, I think, is going to be fine. But I'd caution you, like, eventually it might not be so fine. Right? But for right now, I think it'll be okay. Yeah.
So if it's like, will it always be the top minus the bottom, or just in one time cases where there's like a y value
What you're describing is would always be top minus bottom.
Okay.
All right. Hi, everybody.
Thank you.
I have some things for you to work on. You're welcome.
should we like get them done like next class to go over?
Yeah, we're gonna, next class, I'm gonna randomly call on people to do stuff on the board from this set.
Is this like a fun study method, or is this like a
This is me,
like a quiz?
this is me trying to do something different to get you more feedback
Thank you.
on something that you don't feel very good about.
Would you mind if I stapled this?
We will be.
Absolutely. I didn't have time to say that.
No, you're good.
Because this was literally, I threw this together as something. Brooke, did you get one of these things? Oh, yeah. You did? Okay.
Thank you, Mr. Kulik.
You're welcome.
Cool, I had a little clarifying question.
Yeah, what's up, homie?
So,